Welcome, everybody. So we're going to continue talking about the confidence interval. What I want you to do, I want you to grab a piece of paper and divide that piece of paper into 3 columns. So on the first column, I want you to write down confidence interval for population. Population mean when sigma is given. Okay. In the middle column, I want you to write down confidence interval for population mean when sigma is missing. Very good. And on the very last column, I want you to write down confidence interval for population proportion. Population proportion. Very good. So again, I want you to grab a piece of paper, divide it into 3 columns. On the very first column, I want you to write down confidence interval for population mean when sigma is given. On the second column, I want you to write down the confidence interval for population mean when sigma is missing. And on the very last column, I want you to write down confidence interval for population proportion. Very good. So let's see what we learned so far. Let me open up the note for you. So we are following our notes. Last week, we started talking about 6.1, the confidence interval for population mean when sigma is given to us. Okay. We started by finding the very first thing that was our point estimate. Okay, let us write this down here. So in step 1, I want you to find the point estimate. The point estimate. The point estimate for population mean, it's going to be sample mean. So remember that we denote that guy by X bar. Point estimate or X bar. Very good. In the second step, I want you to identify the confidence level. In step 2, identify the confidence level. What is the confidence level? Remember that if the confidence level is missing, you need to use 95%. So that confidence level, depending on the question, it might be 90%, C might be 90%, it might be 95%, it might be 99%, or depending on the question, whatever that is, if it's not given, they're going to use 95%. So let me write it in a parenthesis here for you, so note. If CI is not given, use 95%. Okay, Very good. This is our step 2. In the third step, I want you to find the critical value. Step 3. Find critical value. Critical value. So in your very first column, the critical value is denoted by Z sub C. Z sub C. How do we find Z sub C? Depending on what is the confidence level, we're going to use either our Z table, old-fashioned way, or use our calculator to find the critical value. So remember that to find the critical value, what you're going to do, if sigma is given to you, you're going to use a normal distribution. Okay, here you have your normal distribution. And then here you have your, for example, C, whatever it is, 90%. This is going to be C, 90%. Remember that 100% minus 90% is going to be 10%. 5% is on the left, 5% is on the right. So this little area to the left, to the right is going to be 1 minus C divided by 2. So whatever that C is, if it's 95%, then you're going to have 5% divided by 2. If it's 99%, then you're going to have 1% divided by 2. Whatever that C is, whatever your confidence level is, it's going to be 1 minus C divided by 2. So to find ZC, to find Z sub C, we use second vars inverse norm, and then we're going to enter the area to be 1 minus C divided by 2. The mean is going to be 0, okay, because we are dealing with Z value, and the standard deviation is 1. Then the positive number is going to be our critical value. Remember that. Positive number, ZC is positive. So if you get a negative number, because calculator calculates the area to the left-hand side and it gives you this negative number, calculator gives negative. The ZC is going to be the positive. So you're going to ignore the negative side and use the positive Z value and call it the critical value, the dividing number between rejection region and non-rejection region. Okay, very good. So in step 4, you're going to find the margin of error. Step 4, margin of error. Okay, you have to follow each step properly to find all of those missing values. Find the margin of error. Margin of error. Remember that we have a formula for this guy. E is equal to Z sub C times sigma divided by square root of n. After finding the margin of error, the maximum distance between the point estimate and the population mean is your margin of error. And in the last step, step 5, you're going to come up with your confidence interval. You're going to say that, hey, my CI, my confidence interval, is equal to parenthesis X bar minus the margin of error, X bar minus the margin of error, comma, X bar plus the margin of error. Then you're going to say that, hey, I am 90% confident. I am 95% confident. I am 99% confident that the population mean is within these two numbers. This is 6.1, what we discussed last week. In majority of project, the statistical analysis project that you're going to do, you are dealing with the cases that the sigma is not given. Sigma is missing. You do not have any information about the population standard deviation. Even if you go back to the main, to the domain expert, the main person who gave you the data, ask, hey, what is sigma? What is the population standard deviation? That person is going to tell you, hey, we don't have that information. You have to take a random sample and calculate the standard deviation for yourself. In the majority of the cases, we are dealing with this scenario. Standard deviation of the population is not there. It is missing. So how do we build the confidence interval? In this case, which is your second column, we're going to talk about t-distribution. Let me write down the steps that you're going to take to calculate and compute the confidence interval for population mean. When sigma is missing, then we're going to go over the details about t-distribution. Okay, bear with me. Step one, as usual, you need to find the point estimate. No doubt there. You always start by finding the point estimate. The point estimate or the best estimator for population mean is sample mean. No doubt there. When you take a sample, you're going to find the mean of that sample, and that represents as point estimate of the population mean, but we need more accuracy. So point estimate, X bar. Point estimate or X bar. X bar, what is X bar? Sample mean. X bar is sample mean. Okay, this is 6.2. In the second step, you're going to find the confidence level. 90%, 95%, 99%, 80%, 85%, depending on the project that you're going to work with. There are research team in that company that comes up with the confidence level. They give you the level of confidence that they expect their products. They are having a very huge and accurate team, research team. They are working on the prototype, and depending on what product that they're using, is it just injection mold, or is it using in, for example, heart surgery? Is it using in eye surgery? Depending on the product that they're using, they give you the level of confidence. If it's not given, if the project manager says, hey, we don't care about the confidence level, just give us something, we're going to focus on just 95% confidence level. In the third step, step 3, you're going to find the critical value, but you are not using Z. You are using something different, T sub C. So when sigma is missing, you're going to find T sub C using t-distribution and your calculator. Luckily for us, the calculator has all the information that we need. So step 3, find critical value. Critical value that we call T sub C. Again, let me point out this scenario. Sigma is missing. The population standard deviation is missing. So you're going to use T sub C. This is important, guys. This is super important. When sigma is missing, you're using a new distribution, T distribution. Okay. How do I find TC? Well, the calculation is almost the same. To find T sub C, you're going to use your calculator. You're going to go to second, vars, and then you're going to go to inverse T. Inverse T. Then there, you're going to enter the area, which is 1 minus C divided by 2. Degrees of freedom, which is N minus 1. I'm going to graph the T distribution after we discuss the T distribution for you. Then in step 4, in the fourth step, you're going to find the margin of error. Okay, margin of error. Well, okay, how do I calculate the margin of error? To find the margin of error, we have a formula. Margin of error, E, is equal to T sub C, the critical value that you found, multiplied by S, divided by square root of N. So you're using TC, that you use your calculator or T table to find, and multiply by S. What is S? S is your sample standard deviation. Divide by square root of. And in the last step, step 5, you're going to construct your confidence interval as Ci, which is equal to X bar minus the margin of error, comma X bar plus the margin of error. Okay, very good. Now let us talk about what a T distribution is and how do we compute T sub C, the critical value. Guys, again, please prepare a paper with 3 columns when you're using this paper to complete your homework, quizzes, and exams. You have all of these steps as your reference, which makes computations much more easier. Thank you, group 1. Thank you, group 2. Appreciate that. So again, in many scenarios, in many cases, the standard deviation of population, which is sigma, is not given. So when sigma or the population standard deviation is not given, we cannot use a normal distribution. We're going to use a new distribution that we call T distribution. What is a T distribution? The T distribution is a distribution that follows T equals to X bar, the mean of the sample, minus mu, which is the mean of the population, divided by S, which is the sample standard deviation, over square root of N. Very good. We use a T distribution to calculate the critical value, which we denote by T sub C. This distribution, as we studied a normal distribution, has different properties. S is the sample standard deviation. So sigma is population standard deviation. S is sample standard deviation. N is sample size. Very good. So what are the properties of this distribution, T distribution? The mean, median, and mode of the T distribution are all equal to 0. So it's very similar to what we saw for a normal distribution, standard normal distribution. of the t-distribution is bell-shaped and symmetric with respect to the mean, its standard deviation is going to be larger than 1. That's the main difference that it has with a standard normal distribution. The standard deviation of a t-distribution is larger than 1. Well, what are we going to do? We're going to compute the degrees of freedom, the numbers of free choices left after a sample statistic like X bar is calculated. How do we define the degrees of freedom? The degrees of freedom is denoted by n minus 1. Again, n is the sample size. Luckily for us, as the degrees of freedom increase, the t-distribution will be very similar to a normal distribution. So after 30 df, or the degrees of freedom, again, df is the degrees of freedom, which is n minus 1. The t-distribution is going to be very similar to a normal distribution. So take a look at this. This is the black graph. The degrees of freedom is 2. It means that the sample size was 3. But if you increase the sample size, the degrees of freedom increase. Now the degrees of freedom is 5. The graph is this gray graph here, the middle graph. And as the degrees of freedom increase, like 30, you get a graph which is very similar to a normal distribution. So these are the properties of t-distribution. So again, when we are constructing a confidence interval for mu, which is the population mean, we use sigma. If it's not given, we use a t-distribution to compute the critical value. Well, what are the guidelines? Very good. The very first thing you're going to do, you're going to find the point estimate, which is X bar. You're going to find the degrees of freedom because it helps you to compute the margin of error. Margin of error, which is TC, S over square root of N. Then you're going to construct your confidence interval. The lower limit is X bar minus E, and the upper limit is X bar plus E. Then your population mean is bounded between these two numbers. You're going to say that, hey, I am 90% confident, I am 99% confident, I am 80% confident, depending on what your confidence level is. Again, let's take a look at the board. These are the steps that we're going to take to compute the confidence interval when sigma is missing. It's very important for us when you're reading an example, checking to see if sigma is there or it's not there. If you use a wrong critical value, your margin of error is going to be different. Your confidence interval is going to be wrong. So it's very important at the beginning, identify if sigma is missing or not. If it's there, well, you're going to follow the steps, compute C sub C. If it's missing, you're going to compute T sub C. So let us go over some examples to feel more comfortable about building and constructing a confidence interval when sigma is missing. Very good. Let's take a look at one example. A volunteer from group 4, please read the example for us.
Okay, I can do it.
Thank you.
Constructing a confidence interval. You randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperature is 162 Fahrenheit with a sample standard deviation of 10.0 Fahrenheit. Construct a 95% confidence interval for the population mean temperature for coffee sold. Assume the temperatures are approximately normally distributed.
Very good. Let's take a look at our board. Let's see what information are given to us. This is the example. So you are constructing the confidence interval for your population what? CI for population. Is it population mean or is it population proportion? What do you see? Are we trying to construct a confidence interval for population mean or population proportion? Take a look at the question. You randomly select 16 coffee shops.